get this going. All right. So tonight we've got Michelle Brachman talking about coding on the fly. And without further ado, I will pass it over to Michelle. Michelle, are you ready to go?
Yep, ready to go.
Fantastic.
Okay, my slides are good.
Perfect.
All right, great. Yeah, so I am going to be talking about coding on the fly needs and support. And I am going to kind of go back in time a little bit to some work that I did in the past in a couple of different places, and then bring it to kind of the future or the current and future in the role that I'm in at IBM. So a lot of this work is work that I did either at WashU in St. Louis or UMass Lowell over the years. So as I guess we kind of all know, millions of people are programming to create all kinds of things. I'm going to talk mostly about this idea of creating artifacts where people are programming to and their goal is really focused on what they're creating. So we can think about applications or games as these kinds of artifacts that people need to create. And we might think of programmers as one particular type of person who's a software developer and has a lot of education and background and experience in programming, but we actually have a wide array of kind of different personas who need to program in order to accomplish their goals or want to program. So, for example, we have children. Children are kind of one of our growing populations of programmers. They're creating animations, apps, and games. They're often novices, although not always. And they are really focused on what they want to create in a lot of cases. So they're thinking about that end goal. They're thinking about that animation or that game that they're trying to create. And they're not necessarily thinking that much about the process of programming or the learning kind of in particular. And this is kind of where my on the fly comes from, is because I'm going to be talking about a couple of different contexts where people are maybe not necessarily thinking about learning. They're not thinking about kind of going through a deep learning process about how to code, but they have a goal and they're trying to work toward it. And then, of course, we have other types of end user programmers as well, people who are analyzing data, people who are creating websites. And again, these populations are kind of just expanding to even greater heights. People have measured the number of end user programmers kind of like a decade ago, and it was already millions and millions of people. And so these contexts that people are using coding or automation for are only expanding. And then, of course, we also have professional programmers, right? And they're also creating artifacts, and the learning kind of doesn't end. It's not that people can go to school and learn a set of skills and then go out and now they're set. They're always going to be something new, some new update or a new framework that someone needs to learn. And so this is kind of coding on the fly or learning to code on the fly is not something that only non-experts need to do. So we have these programmers of a variety of different types. They want to accomplish their goals, and what they actually need to do along the way in programming, as well as, I mean, this is not just a programming kind of context. We can think about lots of different complex contexts where people need to learn along the way, but aren't necessarily focused on that learning aspect. And so that's what I've been kind of thinking about through a variety of different contexts, is these spaces where people kind of need to deal with and process and think about really complex information as they're kind of trying to just accomplish their goal. They're just trying to create their animation and maybe not thinking about that learning process in particular. So I have three kind of pieces that I'm going to talk about tonight. The first is the design and evaluation of a system that suggests example code to novice programmers, specifically young novice programmers. The second is about understanding programmers who are using and learning new APIs. And then the third is about understanding and supporting people who are using natural language to do trigger action programming for business automation. So the first of these, supporting novice programmers. So as I kind of alluded to, we have tons and tons of children who are using artifact-based blocks, often blocks programming environments, not always, and they're often doing this independently. So we can only hope that eventually all kids will get to have a classroom in school where they learn to program, but that's unfortunately still not always the case. And so lots of kids are learning or using programming independently. And this is just one context called Looking Glass, which is a programming environment based on Alice from Carnegie Mellon. And it's very similar to Scratch and other novice programming environments where kids can basically put in these different objects and then drag and drop blocks of code that make those objects or characters move or change in some way to create a 3D animation. And so, so we have these resources for kids to learn independently. We know that kids are really motivated by doing something that's personally interesting to them. And so these independent contexts where kids can create whatever they want and work toward those goals on their own are really important and really important, especially for kids and girls in particular. And so we have these kids kind of learning independently, and they're kind of on their own. And what we kind of saw over and over again is that kids would end up kind of creating these really simple programs. So this may look a little bit complex at first glance, but the main important part here is you can see these blocks are all kind of the same method. They're all say blocks, a couple of different walk tos. So there's a little bit of different code in here, but we don't have any programming concepts. We don't have any complex constructs. The kids aren't really, they're not expanding their knowledge base here. And this is supported by other research where we found that novice programmers, kids are often plateauing in their skills when they're working on their own. So they don't reach out and try to expand their skills for a variety of reasons. They probably sometimes just don't think of it, not that they don't want to. And so we wanted to try to understand how we could increase kids' use of and learning in terms of more complex code without actually forcing them into a tutorial or some kind of structure where they can't focus on what's most interesting to them. So we wanted to keep them in that most motivating context where they're getting to create whatever they want, but also ensure that they were learning along the way. And so what we did was we designed a system called the Example Guru, which is a system that suggests new code through examples in context. And the main idea here was to, again, not sort of force someone down a certain pathway, but make these subtle suggestions that could sort of encourage kids to explore things that we kind of thought they should explore, but they might not seek out on their own. So I'm going to walk through sort of the design of this and the details. This is just kind of a high level picture of what we ended up doing. So how can we design this kind of system to support novice programmers as they work in ways that help them to learn? So to do this, we employed cognitive load theory, and we used that with an exploratory study of example use to try to understand what kinds of information people need, kids need, in order to be able to kind of learn and explore these new concepts. So cognitive load theory is a theory from psychology that talks about the amount of sort of working memory we have and the presentation of different types of learning materials that can sort of either take up our working memory and kind of clog it up with things that aren't important, or we can present learning material in ways that are helpful and supportive to learning. And so one thing that cognitive load theory suggests is that worked examples like these ones that we always kind of used in math classes growing up, I think a lot of us probably saw these, where you kind of see an example of how a problem can be done and it's worked through, you can see all of the steps, and that has been shown to be helpful for learning. And so we wanted to understand if this is something that we could present to novice programmers in this independent context where there isn't a structured task necessarily, but we can still provide this kind of idea of a worked example that could kind of lead these independent novice programmers through programming concepts. And so we wanted to understand more about what a worked example needed to look like. So first, we wanted to study that in kind of a controlled environment where users did have tasks, and we wanted to see if we could give examples or provide examples that would help them to solve those tasks. So we ran an exploratory study where we had pairs of kids work on coding tasks, and we provided examples along the way. And so there were a couple of kind of key features of this study. One of them was that we had pairs of kids. And this is something that was really important for this study because the kids who were working on these tasks didn't necessarily feel comfortable talking out loud about what they were thinking about, but that was so important. It was kind of the main core piece of what we were trying to figure out is what kids were thinking about, what they were looking at, and how they were using the examples to solve the tasks. And so by having these kids work in pairs, they talked to each other about what was happening on the screen, what was happening in the task, which pieces they were finding hard or easy. And so this was really, really helpful in kind of understanding better what the kids were thinking about. So we had a training task where they were kind of getting familiar with the system, and then we had these coding tasks with examples provided alongside of them to see if kids could use these examples to complete tasks. So as an example of what these tasks look like, we have this pig. I don't know if it's kind of easy to see, but there's a pig here and he's on a deserted island. And there's a helicopter. And so the idea here was that the kids were trying to get the pig to wave for help. And so what they needed the pig to be able to do was raise both of his arms up and then both down. But what's happening in the task originally is that the pig is just raising one arm up and down, and then the next arm up and then down. And so they saw alongside of this task, this example, where there's a do together concept, which makes things happen in parallel. So this was basically showing an example of how to make things happen in parallel. And if they completed the task successfully, the idea was to add these do together code blocks into the code so that the pig would raise both of his arms up and then both down at the same time. So we had 6 of these tasks like this where we were showing users the code and then asking them to try to modify that code with these examples. And we thought that providing some highlighting of sort of the core concept and providing a way to execute that example would be helpful in solving these tasks. And so these seemed pretty simple and straightforward to us. It turned out that these were really, really hard. And these examples were also much kind of more difficult to use than we thought that they were. And so when we're thinking about these kids with basically no programming experience, there was a lot to figure out in this context. And so we recorded what they said. We also asked them extra questions if they weren't talking a lot to kind of capture what was happening. And then we performed a qualitative analysis where we were taking all the transcriptions and grouping those. And we were focused on 2 kind of main parts of what was going on, the focus area, so what part of the interface they were talking about. So were they talking about the example code? Were they talking about the programming environment? Basically, which part of this? And then what part of the process were they in? So were they trying to solve the task? Were they trying to understand something? And so we used that to establish some hurdles and strategies that the participants were using to try to use these examples. And so we wanted to use kind of these issues that people were having to try to improve the example design. So for example, participants had example comprehension hurdles. So they didn't actually understand how to use the example that was provided in the format that it was provided. So one participant said, play example. I don't get how that's supposed to help us. Yeah, I have no idea. So even though there were sort of instructions and it seemed really straightforward, they didn't actually understand that there was an option to execute the example, which was really problematic, especially because that was kind of the core focus of how they would understand how the code worked. And so we modified our design to focus much more on the execution of the example, because that really was the kind of the way that they could sort of work out the example, see what the effect of the code was to actually see the example and how it ran in the code. And then we also found that participants had trouble finding information in the interface. So participants didn't know, once they kind of knew what they were supposed to do, they didn't necessarily know how to execute that. So one participant said, then you do repeat 2 times. How? But it says that you can repeat. Where is the times thing? I don't see that. So even though they kind of knew what they were looking for, they didn't know where to find that information. And so we added a capability within our examples to actually point the user to the concept that's suggested in the example, to remove that barrier of not knowing where to look in the interface for what users were trying to find. And then finally, we noticed that participants who were successful often made comparisons between their own code and the example. So one participant said, not is true, but here it's just is true. That looks like the example, but it's got this not thing. And so this was their code and this was the example, and they were noticing that they had missed something, and there was something in the code that they could be using that might help to make their task correct. And so we thought that it would be useful to provide a more natural way to kind of show different versions of the code to enable users to naturally compare like different parameters, for example, or different versions of the code. And so we, each of our examples, we provided 2 of these examples so that they could see different versions of how that particular code worked. And so we felt that these improvements to our design, they kind of aligned with literature in example use and how examples should be provided. And we wanted to understand if users would actually kind of go out of their way to use this, if we provided these examples in a context where we weren't forcing them to use them, and participants were actually creating whatever they wanted, as opposed to us giving them a particular task. So in order to be able to do that, we created a set of these examples and suggestions. And we did that by taking a set of programs that people had created. And from that, we created examples that introduced code concepts that more advanced users were typically using, but newer programmers were often not using. And our goals in these suggestions were that they should always improve the artifact, so the animation. We never wanted to provide a suggestion that improved the code, but not the animation. So for example, if a participant had 3 lines of code that were repeated, we didn't want to just replace that with a repeat loop, because that would only improve the code, but not the animation. So instead, we might want to introduce a repeat loop in a way that actually improves the animation as well. We wanted to make the example simple, so we only introduced one new code block at a time, and we wanted these to be introduced kind of in natural ways and ways that didn't force the user to use them. So they basically showed up alongside the code near the code blocks that were available. And we created these static rules that triggered the suggestions based on the user's code. So they were context dependent. This is something that you could expand if you had a really large set of code. You could expand to do it sort of create those rules with machine learning, but we had a small data set, so we created the rules statically. And then we wanted to understand, again, are novice programmers actually going to use these examples? Do they find them helpful? Does it actually improve their code, which was really our goal? So do novices access and use our suggested examples? And so to understand this, we ran a study where we had half of our participants receive our suggestions, and half of the participants receive static documentation. And so in the static documentation, there's basically just, it was always available. It's just a static set of examples. They're not contextualized to the programmer's code, and they also were not coming up dynamically. They were just constantly available. And this is kind of the state of the art of support in these kinds of environments. And so that's why we use this format of control to compare against. And so we had 78 participants who split between these two conditions, and they were allowed to just program on their own. We gave them suggested ideas if they couldn't come up with something they wanted to program, but otherwise we just let them program whatever they wanted. So we didn't have any restrictions. And we found that participants accessed significantly more of these suggestions than accessing documentation. So on average, about twice as many accesses to the suggestions than documentation. And you can see this is only 3, so that might seem very small, but it was only a 30-minute session. So we wouldn't sort of be expecting people to be constantly accessing suggestions. We would sort of expect them to code some and maybe notice them at some point later and sort of use them intermittently. So accessing 3 over a period of 30 minutes is kind of a reasonable amount of access. And then we also wanted to know, okay, well, if they were accessing the suggestions, but does that actually translate into integrating that new information into their code? And we found that participants also used significantly more of the suggestions than the examples that were provided statically. And so again, this was a significant increase in the use of these suggestions. Also, very small numbers because they only accessed about 3. So using kind of close to 1 over the period of 30 minutes, we felt like was a pretty good turnover rate in terms of actually applying those suggestions to their code. And so what do we kind of learn from this? So our suggested examples did increase usage of new concepts in these open-ended contexts where the novice programmers weren't being required to use anything, and they were kind of just working independently on something that was motivating to them. But basic examples aren't enough. There's a lot more sort of support needed for this kind of example in order to enable a novice programmer to actually take something that they see and translate it into their own program. So they need to understand more about how it works and actually how to apply those examples. So I think this kind of showed that we could kind of think about ways to introduce learning opportunities into a situation where a programmer is kind of working on something and not really thinking about that learning context. And so our next thought was, okay, well, can we integrate this into other contexts? So we had sort of introduced these really basic concepts to novice programmers, and it seemed to be effective. And so our next kind of thought was, well, maybe in other programming contexts where people need to kind of learn and code on the fly, we could provide similar kinds of suggestions. So we thought about the context of programmers who are learning and using new APIs. And we discovered that we didn't actually know enough about this context to really be able to say that our solution was going to apply in that context. And so we ended up thinking a lot more theoretically about that context and trying to make sure that we understood the holistic kind of API learning context, which is very clearly much more complicated than kind of a basic programming context. And so what came out of that was sort of thinking more about how programmers are learning these APIs and what kinds of support they need for being able to learn alongside that process. And so code libraries or APIs, frameworks, I'm kind of using all of those words a little bit interchangeably, but these pieces of code that programmers are importing into their own programs that they don't actually, they didn't write them, they're reusable pieces of code. And these are critical for programming. They're kind of the backbone of a lot of code currently. And with like sort of open source growing and inner source, these are sort of necessary and important regardless of sort of what kind of coding context you're in. However, research has shown that API learning is really difficult for a variety of reasons. So documentation can be missing or problematic. Examples that people provide through question and answer forums might not be helpful or might not be relevant. And so there's just a lot of issues with learning these APIs. And again, it's something that people are often doing as sort of part of a project that they're on. They may not have time to sort of set aside a big chunk of time to go through a formal course or a formal tutorial in order to learn about a new piece of code that they're working with just briefly. So there have been identified sort of these hurdles and challenges that people have while learning APIs, but we felt like we were missing sort of the larger context of what was going on as programmers are trying to learn a new API. So what was their process, and where was that breaking down, and how could we help them in that learning process? And so the way we went about this work was we wanted to analyze the holistic API learning process using a model of API learning. And then we ran a user study where we had participants learn React or try to learn React, and to see if our model was capturing the API learning process. And our kind of high-level findings were that our user actions were aligning with our model, which I'll talk about in a second, and that one of the main kind of things that we saw was that people were trying to store a lot of information that they were finding in what we call external memory. But that was a really problematic process because there was so much information that they needed to store, and it leads to sort of problems down the line. So first, I'll talk a little bit about the model that we were working with. It's called the Coil Model, which stands for Collecting and Organizing Information for Learning in the context of APIs. So there are basically three main stages: the information collection, information organization, and solution testing. Although we don't expect these stages to be sequential, and we also don't expect them to only be one of each of these stages. So we can imagine this process is a lot messier than just these three kind of boxes. And so we also want to think here about how people are processing information, right? So as people collect information, they're having to perceive that information, right? Make sense of it with their eyes and their memory. They're needing to store information in their short-term memory and also hopefully in their long-term memory as they're learning these APIs. And so that's also going to be relevant here. And so we expected there to be an information collection stage where we were thinking about information foraging theory, which talks about how people seek out information and how they look for information in sort of the field of what's available. And so in the information context, we would expect people to be looking for information, making sense of the results that they find, making decisions about whether that information is what they need, and then of course navigating to that information or not, depending on whether it's relevant or not. And then we have the information organization phase where we leverage research on external memory about how people store and retrieve information. So external memory we can think about as for example, a shopping list. So when you are, throughout the week, maybe you're thinking about what you need at the grocery store and you realize you need ketchup, but you might not remember later in the week that you need ketchup, right? So we can store that ketchup on your shopping list. And this is a way to put that thing that was in your brain that you would otherwise have to sort of keep there and remember and bring back into your memory. You can put it on that external memory shopping list, and then you don't have to keep it in your memory anymore. And so the same kind of idea applies when people are dealing with a large amount of information, is that some of it needs to be stored in external memory because it just can't all fit in our working memory. And so we expected that external memory would be a part of this process as people are kind of sifting through all of the information that's available as they're learning an API. And then finally, people need to actually take that, whatever information they found, make a decision about what they think is going to be most relevant and take it into their code context. So that could involve editing the code, running their code, checking the results, reading their code, all of these sort of code context items. So then we wanted to understand more about how programmers were moving between these stages and the actions within these stages in order to understand more about where programmers are spending their time as they're trying to learn an API and which of these stages are inefficient and problematic for those programmers where they get stuck. And so we sort of expect a flow from information collection through organization and testing, and we expected it to sort of loop back through information collection and back around as people kind of found things that didn't work and then needed to return to information collection. And so to study this, we recruited computer science students from UMass Lowell computer science mailing list. So we were looking for people who had some programming experience, but didn't have experience with the React API, so that they could leverage at least some of their programming experience, but also need to actually learn some elements of React in order to complete the task. And so we gave them a task in React, and the goal was that they would create a text box and a button, and the button would initially be disabled. And that when they typed in the word friend, that button would then become enabled. And the reason that we designed this task, it's maybe not the most complex task, but actually was really, really difficult for people. And literature has shown that when learning a new API, having to actually connect multiple components is really challenging. And so we wanted to have these two components that people had to figure out how the input of the text box could interact with the button and actually make changes. And so we gave this task in, participants had access to Chrome and Atom, and we instrumented both of these environments so that we could track all of the actions that programmers took in both of the environments. So we had extensions in both contexts, and we tracked all of their searches, the tabs that they had open, whether they copied information from one environment to another environment, and all of their code editing that they did, as well as whether they were testing their code, for example, by refreshing the localhost page or visiting the localhost page to see how their code worked. And then we wanted to, again, know how people were moving around in these stages and actions based on the model of API learning. And then we also had a set of hypotheses. I'm just going to go through a couple of these that I think are the most interesting and talk about those. So first, how did they move through their stages? So based on our action logging, we were able to track sort of how people moved from each action to each other action. So this chart shows sort of if somebody started in search, this is kind of the frequency of how often they went to a new page after that. So the thickness of the line is indicating how often that action took place. So the thicker lines took place more often, the thinner lines took place less often. And then we have each of the different stages of the model in different colors. So in information collection, people searched and then went to new pages. When they were organizing their information, they closed tabs, or they organized their tabs, or they went back to tabs that they had gone to in the past. And then there were solution testing actions where people were editing and testing their code. And so the thickness of the lines, you can kind of see where the most frequent actions were. And so one of the things that we found was that participants were really often returning to previous pages. So we can see this return action that was happening a lot. And this was happening a lot more than sort of new searches or searches going to new pages. And so this kind of told us that there was a lot of action here happening in this information organization phase that had been sort of relatively unexplored in previous research. And we also noticed, as might be expected, that there was a lot of actions in the solution testing phase, going between editing and testing. And this was something that we also wanted to explore further to find out what was happening in these editing and testing phases. And so we wanted to dig into these further because we wanted to really understand what information people were taking from what they found in their kind of information seeking, and how they were using that in their programs. Were they succeeding? Were they actually able to find information online that they were then able to use in their task? Or were they finding examples and then not actually being able to make sense of them enough to integrate them into their own code? And so we looked at whether people were pasting kind of whole examples. So were they taking, a whole section of a Stack Overflow page, or were they selecting particular parts of those examples, which might indicate that they were thinking more deeply about the example and had kind of a better idea of which part of the example they needed to complete their task. And so we wanted to look at those, as well as whether people actually then kept those examples in their programs, which would indicate that those examples, the participants thought that those examples would help them to solve the task. And so here we have sort of the graph of actions, again, with thicker lines indicating that those actions happened more frequently. And so we can see that participants were pasting whole and partial examples, although partial examples slightly more often. And then there was a lot of modification of those examples. So people were not able to find code examples that they could just immediately put into their code. They needed to do a lot of modification of those, and went through undoing and redoing in order to get to what they needed in order to keep their examples in their code. In contrast, when participants ended up deleting their code, so again, they pasted whole and partial examples, but often ended up deleting or completely undoing their code to get rid of the examples they pasted in. And in these cases, there was much less modification. So maybe participants didn't know how to modify what they needed. And in a lot more cases, they sort of pasted the whole thing and just sort of deleted it, which may indicate that they were either just storing the example there to see if they might need it later, or they might have been sort of like pasting it in, but then not actually having any idea about how to modify it in order to keep it into their program or to use it in their program. And so this may indicate that there's sort of a need for a way to either store examples that people have found. That doesn't mean like directly pasting it into your program and then needing to delete the whole thing later. But there's not really a very good way to deal with those examples that people found other than that. And so that may indicate that there is sort of this need for ways to deal with external memory more effectively. So next I'll talk about our hypotheses. So one of them is that we expected that information foraging, where people are searching for information, would be kind of ineffective, that people would have trouble finding the information they needed, and they would end up discarding a lot of information. And then we also believed that people would do a lot of storing information in external memory and also retrieving that information. And so because there's been such a focus in the past about sort of how people find information and all of these like needs for supporting the information foraging and finding process, we really expected this to be a main activity. But actually only 15.6% of participant searches led immediately to new searches. So this kind of loop here where people are searching and then searching again was not that common, which meant that people were often more often finding what they needed in their searches, or at least thinking that they found what they needed. So they were navigating to those new pages and at least exploring those new pages before returning to searches or other pages. And so we really felt like this was kind of surprising information that that people were not having so much trouble in finding the information that they thought they needed, but instead they were searching for information and collecting that information and needing to then compare that information to sort of make sense of it. It may not be immediately obvious to somebody who's learning a new API whether information is useful or not. And this was sort of shown by the ways that participants dealt with the information that they found. So this chart is showing over time how many tabs participants had open. And so we have 5, 10, 15, 20. So we had quite a few participants who had quite a few tabs, between 10 and 20 tabs open. And from these lines, we can see that in many cases, participants kind of kept opening new tabs, and they opened new tabs, and they weren't really getting rid of a lot of their tabs. It happens a couple of times, this blue line, they kind of deleted all of their tabs, but in most of the cases, the number of tabs kind of increases and rarely decreases until maybe the end. And so what this kind of tells us is that people were collecting all this information. They were searching, they were finding new information, maybe going from one page and opening new pages from that, and not really getting rid of that information, but instead collecting this set of resources that they then thought might be able to help them solve their task. Again, maybe this isn't surprising. Maybe this is something that all of us have done, not just with programming, but anything, right? I mean, if you're going on a vacation, you're probably collecting a lot of tabs in your browser to find out all of the different restaurants in the area of your hotel. And so maybe this is not completely unique to programming. But the thing that is unique to programming here is that, once you've found your hotels or your restaurants, you can make a list of them and carry on. But in this context, people are needing to learn. They need to actually make sense of all this information in a way that then creates structures that they can understand and they can integrate into their programs. And so having this sort of mess of pages that fill up your browser that you don't really have a way to kind of keep track of or organize in any kind of reasonable way, I think becomes a lot more problematic in the programming space or in spaces that have this complex information that you actually need to learn. It's not just sort of things that you found that you can then decide whether you want to put on a list or not. And then we also found that people were retrieving this information. So it's not just that they stored it and that they never went back to it, right? So people were actually, this is a returning to the page. So this was a very, very common activity to return to a page, not just from other pages, but also from testing out their programs as well as editing their programs. And so a lot of these activities led people to return to their pages. And then we also found that in a lot of these cases, when people were returning to these pages, they were only there for fractions of a second, which actually probably indicates that they were like sort of sifting through the pages that they had found, trying to find the one that they wanted in particular, which again is sort of reinforcing this idea that that this 10 to 15 to 20 pages stored in their browser was maybe not the most effective way to collect resources to learn React from. And so what this kind of tells us is that supporting, organizing, and refinding information when learning programming on the fly is a space that we probably could use some help in. There are some tools that are kind of starting to try to address this, I think more recently, and I'm sure people have their own ways of managing this, but a lot of our programmers kind of didn't. This also makes it really hard to compare code. So, we saw some ways that people were doing this. Maybe they were bringing their examples into their code so they could then compare it. But it's really hard to do this from the browser. And it's also really hard to determine if something is going to be useful and how to integrate it. So people really didn't seem to know if something would be useful in advance. And even if they were pretty sure something was going to be useful, it took a lot of work to integrate it. So this wasn't a straightforward process. And so I think there's a lot of space here for supporting programmers even more in these kinds of contexts where they have to learn on the fly and make sense of large sets of information, which I hope can be addressed sometime in the future. But with that, I will sort of jump a little bit to something that I've been working on more recently. So, and this is about understanding and supporting natural language trigger action programming, which I think in a lot of ways is connected to these pieces of work for this idea of sort of needing to process complex information and really learn about something. And not just sort of perform actions, as people actually need to learn as they're trying to accomplish their goal again. So trigger action programming, if you're not familiar, is a way of programming that's kind of catching on. I would say one example of this is if this, then that. So we can think about like smart home devices with programmable rules. If it's Friday, turn on the light at 6 a.m., for example. So trigger action programs typically have events, something that occurs. It could be a schedule or it could be some other kind of event. And then they have actions that then happen afterward. So there are lots of systems that enable people to create these kinds of automations, either for personal uses like in smart home devices or in business automation. So this is kind of a growing area is to enable business automation with trigger action programming. And so in our context, that is IBM App Connect. And this is an example of one of these programs. So what happens here is that there's an event, and when there's a new attendee, then a Gmail mail is created. And so what we're trying to do is make this process even easier so that the programmer doesn't have to actually learn some kind of GUI programming environment that is unfamiliar to them and has a huge number of capabilities and options available. But instead, we would enable the user to write a natural language utterance or phrase or sentence, and we would actually just translate that natural language into the program for them. So there's sort of two steps of automation in this. We have the program that's automating a set of tasks and automation of the creation of that program through natural language. And so again, here, the user's goal is really this automation task. They want to set the alarm. They want to transfer the data. They want to make something happen more quickly. They want to automate something that's they're having to do manually on a regular basis. But there's a lot of things that they don't necessarily know about this task, especially when we're dealing with natural language, because we've now sort of abstracted this process to a whole nother level. So how can they interact with the system? What kind of natural language does the system need? What are the capabilities of the system? And then, of course, we have programming concepts. So we can add in conditionals, and we can add in loops, and we can add in sequential or parallel programming. Or, we can add in all of these programming concepts. So we have not only this programming concept, programming concepts that people may not know, but also how they can actually interact with the system. And so there are lots of ways we could help users with this that people know about. We could explain things. So there are lots of ways to explain natural language processing systems, right? We could highlight words that are relevant. We could provide text explanations. We could provide rules that describe sort of what's happening within our system. So that's all, great. We could also try to teach people about how our system works. So we could teach them about the system itself. And we could also teach them about how the natural language is being processed so that they could use it more effectively. But then we're sort of losing a little bit of the benefit of doing this on the fly. If we have to learn about all of this context of the system and how the AI works, we are no longer sort of improving the efficiency, which is one of the goals that we were really trying to accomplish by doing all this automation in the first place, right? So I think we really want to be sort of providing this information in a way that people don't have to put in a lot of effort. But either way, this kind of task requires a lot of the same kind of processes as when people are learning in different ways. So we have to process complex information, right? So if we provide explanations, we're sort of transferring knowledge from how the system works, and people have to make sense of that information. And then we also have to manage people's impressions of this kind of system. So how do people think about automation? How do they think about a system that's taking their natural language and creating a program? How does that fit into the understandings that they already have about code or technology or natural language processing or natural language kinds of systems? And so we actually end up with a lot of sort of pieces of this that we have to manage, and we have to support and make sure that we're not sort of clogging up people's processing systems and their working memory with lots of extraneous information that's not actually supporting them in their end goal, which is to automate whatever task it is that they need to accomplish so that they no longer have to spend all of their time doing that. And so some questions that we've been thinking about, unfortunately, I don't have any answers for you on this one, but we've been thinking about how explanations or other methods can support this on-the-fly trigger action programming with natural language. So what kinds of information can and should we be providing where we're not causing them to have to learn a lot or go through a lot of extra work. And then this is kind of tied into how we can think about enabling users to improve over time. So, interacting with an intelligent system can be a little bit tricky, and it's not maybe something that you fully understand on the first try because it's hard to understand their capabilities. And so thinking about there's a lot of people thinking about how we can make sure the intelligent system gives the right answer, but we know that that's not going to happen all the time. So if we can enable users to improve their interactions with the system where they can meet the system in the middle and actually understand what it's capable of, then maybe they can get better outcomes without requiring that the system be exactly perfect. So those are some kind of spaces that we're thinking about in this context at IBM. And so I want to wrap up with kind of what does all of this kind of mean? So I think that in programming, but also other complex tools, using them involves learning them. It's not just enough for them to be able to use them and understand kind of what the functionalities mean, but we actually have to learn them because there is a lot of complex information, and processing that information is really is a learning process. And so thinking about those complex tools and complex systems in terms of learning can maybe help us. I think examples are really important, especially enabling people to use multiple examples. That's been the case in programming in particular. And I think it extends out to other contexts as well. And then finally, learning can and probably is often an iterative process. And there's a lot of information gathering that needs to happen. People are storing that information in internal and external contexts. They're organizing that information in internal and external contexts, and then they're using that information, which can hopefully tell us a little bit about what they've learned or if they've learned. But that iterative process, I think, is really important, and we need to sort of consider what's happening in that iterative process and where people are spending their time so that we can better understand how to support them in these learning processes. And with that, I really appreciate your attention, and I'm really grateful to have gotten to talk to you tonight. Happy to answer your questions.
Thank you so much, Michelle. This is super interesting. So yeah, we will open it up to questions. If people want to type it, you can put it in the chat. If you want to just speak it, feel free to raise your hand. Yeah, so any questions from anybody? Well, I guess I will start off myself. I had one. So I'm really curious if there's any correlation between closing browser tabs and quality of learning. Like, did you find anything about that?
That's really interesting. I don't think that we've necessarily found a correlation. I think we really didn't see that much of it. So it definitely would have been challenging to find anything about that in our small sample. I think that probably what we would have seen if we kind of looked at that in ours is that people close things when they feel like they've sort of finished a piece of something. So there were kind of several subtasks within the task, and that sometimes that like goes along with like completing a piece of that task. But yeah, that's interesting if organizing or like being able to kind of keep track of and organize all of your tabs meant that you could sort of process things better. It's a good question.
All right, somebody else had a hand raised.
Yeah.
David, go ahead.
Perfect. So truth be told, I'm a developer that has done API work. And kind of my question is did you find that when people were returning to specific tabs, that they tended to be more of like the source of the API as opposed to a secondary resource like Stack Overflow or something along those lines?
Yeah, this is interesting. So like what were they actually using? So in most cases, the kind of core documentation was something that people used kind of at the beginning when they were kind of trying to get a high level overview. And then what they were focusing on was really more specific websites that were focused on like the particular piece that they were trying to work on, which I think were more often going to be something like Stack Overflow, but people also used a lot of other, like sort of surprisingly to me, a lot of other blogs and YouTube videos and like code snippet example web pages where you can try things out. And so those were all kind of mixed in there. It wasn't sort of focused only on like question and answer websites. Yeah.
Interesting. Thanks.
Yeah, maybe we could break down thinking about the API, learning to use the API process a little bit. So, when you come to an API, say, hey, I heard about this React thing. People tell me it's good for writing user interfaces, okay? And you come to it kind of like that, right? But you don't really know, is the vocabulary that it uses the same vocabulary that I'm going to think about the problem with, right? And if you see an example in the documentation, one of the biggest problems is that the example usually assumes a fair bit of context, usually a lot of context, either in terms of knowing the programming language or in the intended context for which they use. And you can kind of see it from the point of view of the documentation writer, because they're not going to reproduce the context in every documentation entry. But then, you swoop down and come into it and you don't have the context, So a lot of times that's why when you just, read the thing, oh, it does this. Okay, I want to do that. I'll put that in my code. And then it falls on its face. It can't do that, So that's kind of often what happens. Often what, the way to deal with it is you start from what I deal with is that you start from looking at the example you were given and making sure that the example you were given does what it says it's supposed to do in the context that you're doing it, okay? And very often, a lot of APIs just fail that test, And then if you get it, so, okay, I did their example, and then, okay, now I understand it, so I can put it in my program, except kind of not really, right? So you have to then go back to that original example and maybe do a few modifications of that example to get it a little closer to what you're trying to do. So you can see what the variation of what the API can accept is, right? And only, and then you have to simplify your code because your code is too complicated and takes too much context. So then maybe you have to pull some stuff out of your code and then get an example that's simple on your side, right? So that, you can gradually get your context and the API context to meet. And, that's kind of the way I've successfully learned some API. But it's pretty, that's a pretty tough procedure, because it involves a lot of back and forth and a lot of, copying and pasting. And so, it's going to be tough to track all that, and understand from the high level why the programmer is doing all this stuff.
So what do you do with all your tabs while you're doing that?
Well, I never delete tabs because, as the process goes on, I'm going to say, oh shit, because the tabs are my memory. The tabs are my external memory that you're talking about, right? And so you never, once, if you're 3 steps down the line and that step fails, then what do you got to do? You got to back up to the last place you knew it worked, and then try to move forward in a different way from there.
Yeah. Yeah, it's complicated, right? And yeah, I don't have an answer for it yet, but I do think that we could be doing something better. I do. I strongly believe that we could be doing something better to support people. And I mean, there are things, right? I'm not saying that nothing exists. So, there's starting to be sort of automated code completion tools out there, right? And so if we can do that, then, maybe we can do that for APIs. And so, not just like, regular programming, but actually pull in an API. And so then if that works well enough, maybe that starts to hit at this solution. But I also think that the process that people are kind of going through right now could be improved, right? If we can improve that process in some way. And I think there's a lot of that in, like I say, not finding the information, but then actually dealing with all of the information and dealing with the code and integrating the code in.
Just a quick question on the example guru thing. You probably said this, but I kind of missed it. What is the relation between the example the student is working on and the example you give them? Do you just have a set of examples, or is it tailored? And I got the impression it was tailored in some way, but I wasn't sure how it was.
Yeah, so in the first study, when we were just exploring the design, we created specific ones to fit the tasks. But in the open-ended context, we basically took a set of programs that people had submitted to our online community, and we made a set of examples based on that. So we were trying to make them kind of fit a bunch of different like generic scenarios, like making something jump, like kind of core animation ideas that we thought kids would want to use, making people spin, making people do flips, things like that could be useful in a variety of contexts. And so they were purposefully generic so that they weren't, made to fit an exact program that anyone was working on, because the kids got to make whatever they wanted. And these were just a set of suggestions that we had pre-made. With the idea that hopefully in some future world, you could be taking a community of programs and pulling out these examples automatically and generating the rules and, having it be sort of this iterative loop process.
Okay, thank you.
Yeah.
All right, we have another question from Maureen. Maureen, do you want to speak your question or have me read it for you?
I can speak it. I'm just wondering how old were the children in the studies, and could their age, developmental stages, language abilities have contributed to the difficulties they had?
Yeah, so they were middle schoolers, about 10 to 15, I believe. And yes, it's possible in some cases that, on the younger side of things, that maybe they were having trouble due to that. But I think it wasn't the common case, I would say. Yeah, but that's a good question.
Thank you.
Yeah.
Oh, I think we have, sorry, I can't pronounce your name.
Aprajita. Hi, I'm Aprajita.
Go ahead.
This might be just kind of mixing both of your studies. Very interesting talk, by the way. But I was wondering if there was a way to strike a balance between the context-aware dynamic hints and tips that pop up in place and the external memory that people use. What would be a balance between both?
A balance between providing in-context suggestions and external memory.
Yeah, the browser tabs that people are talking about.
Yeah, that's a good point. I mean, sort of off the top of my head, I could imagine, a system that that knows something about your code and your browser tabs and is actually connecting them, so that you're actually like, as you're working, the browser knows more about that and makes it easier to process, or like easier to organize your tabs. Like it's doing something in the background for you. So it could be doing that, and also then like finding other relevant code examples that you could compare to, for example. So maybe it's keeping track of all of that. As I'm saying that, it sounds a little bit scary. It's keeping track of everything you're doing and recommending, and also connecting that to your code. But I do think that that's one thing that we could think about, is like a more intelligent way of organizing tabs. Like if something could do it well, then having more help with that, I think I would find helpful. And so you could think about like timing of when you used it and what code it's associated with, as well as like, processing, information that's in a page and grouping pages automatically that are related, or that you sort of went to one to the other, right? So I think there's a lot of things you could do there to keep track of what people are doing in their browsers, and then possibly make that external memory organization process smoother.
Thank you.
Yeah, that is such a good idea. Yeah, any other questions?
If anyone wants a side project, I would use that tool.
I have one more question.
Go ahead.
So is this study more or less as to help programmers or developers with API specifically, or is there kind of like a business side of things as well? You talk about workload with developers and trying to take on more work, from a business aspect of things. Can you elaborate a little bit more on that?
Yeah, so the first two projects I talked about, I was in universities, so those did not have business context. They were purely sort of helping people. I'm not sort of, right, because it theoretically could improve efficiency, but I think that there's like bigger problems there in like, for example, like students who come out of universities have a lot of trouble learning APIs. That was something that we really found. And but they're kind of critical. You need to be able to learn those quickly in order to sort of function in software jobs. So I was thinking about it more from that context of like, we have people or people who have been, working in one context for a long time and want to switch to a different context, and they have to do a lot of sort of quick learning in order to be able to switch projects or switch jobs or things like that. So that's definitely how I was thinking about it. I'm sure it would improve efficiency too, right? If we could enable people to sort of bring code in more quickly and deal with their tabs more efficiently. Yeah.
Okay, thank you.
Any more questions? Oh, we got one. Mary, do you want to speak your question?
So I was wondering, I was wondering if you had actually done any studies with more experienced programmers. So like had a lot of newcomers. And then so what I was curious about was, have you looked at how these in-context hints affect the experienced programmers as well, so as to not overwhelm them with information they may not need anymore?
Yeah, no, I haven't yet. It's something I would really be interested to do, because I think thinking about so I basically have only studied this with kids, but I do think that when we're thinking about like APIs and not only sort of like the external ones that everyone knows about, but a lot of companies also have internal libraries and reusable code that people need to learn and maybe could be more efficient, or that their job could be a lot easier, right? if they realized that there was some piece of reusable code that they didn't know about that they could be using. And I think that's a really big, a much harder problem to tackle is to be able to provide that kind of suggestion that would be accurate enough to be helpful in a real world context, because there's just so much complexity. And we don't, like, if we know what the task is, that makes things a lot easier. But we sort of have multiple things to infer, which is like, what is their task? What are they trying to do? What's going to be useful? You know, what are their goals? And so I do think that's a harder problem, but it is something, I mean, there's been some work on sort of like recommending examples and helping people find examples that starts to tackle that. But I think hasn't gotten all the way there in terms of being able to sort of suggest that you should be using some code library that you're not using that might actually be improving your code a lot or improving your process a lot.
I guess maybe I had one, try to formulate it. So you talked earlier at the beginning about like working memory capacity. So I know like different people have different capacities. Does that change the design of the programs you create?
So it's not something that I've gotten to yet, but I do think this is an important piece of it, is that, you know, people are processing all of these different contexts really differently. And it does depend, right, on like how much knowledge you already have about something. So like even a novice programmer who like has some information, or maybe somebody who's like learned a similar API might already have sort of the framework for how to make sense of this information. And so, yeah, it's going to change like how much, you know, how much working memory different information takes up, because they might be able to map it to something that they already understand. And so, yeah, I think that is a big factor in things. And that's something in the work that I'm doing now about like natural language to trigger action programs is something that I've really noticed, is that there's like a lot of individual differences. And they're like not just in programming, but also in sort of like understanding of different aspects. Like if you have a domain that you're working in, like a business domain, there's the business domain knowledge, and then there's also the programming knowledge, and then there's also the AI knowledge. So it gets really complicated in there with like all of those different levels of experience and how they impact sort of how much somebody can process, and how complex somebody considers a task versus someone else. So yeah, that's definitely something I'd like to explore in the future.
Thank you.
Yeah, thanks. These are awesome.
I know a lot of questions tonight. Any more questions?
So, you know, as a developer too, one of the things that comes to mind is also, you know, testers who, you know, might not necessarily have the same knowledge of how an API works, right? And so when you start dealing with automated testing tools, you know, that could potentially change how these APIs are getting tested, right? So like, has that been kind of considered along with this process?
Oh gosh, automated testing tools?
Yeah, simple ways of just simply testing, you know, either an API call or a series of API calls, kind of to ensure that, you know, hey, it's doing what it's supposed to be doing, and then we didn't break anything and that sort of thing.
Mm-hmm. Yeah. No, we only considered people testing their own code. So they were running their like viewing the output, since it was a visual output, they could view it, but we weren't considering automated testing. But I think that could be an interesting piece of this, because if you have automated testing, maybe you can use that to sort of determine if a piece of code that you're suggesting is actually going to work. because you could sort of, the system could in the background, like, go in and say, okay, well, if we put in this API call, would that break the test? So if you had that, maybe that could actually sort of improve that process. Yeah, that's an interesting point. So many open problems.
Any other questions? All right, going once, going twice. All right, I guess we'll call it a night. Thank you, Michelle, so much for this wonderful talk. Really fascinating, and thanks to everybody else for all the amazing questions and great dialogue. So, yeah, I guess we'll be posting the recording on our YouTube channel in maybe a week or so, whenever I get to it. And yeah, hope to see you all next time in December.